Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here we are given with this detonator where people go for a ride and they accelerate straight downward from rest to 45 miles per hour in just 2.2 seconds. Now we have to calculate the average acceleration of the passenger on this ride. This question is very simple. We are given that it starts from rest, so initial velocity would be 0. V0 we can equate it to 0. The final velocity becomes 45 miles per hour. And time it took to achieve this much of velocity is 2.2 seconds. Now acceleration, we know it is delta V over delta T. This thing we have studied earlier. This is the average acceleration. So VF, V final minus V initial divided by T final minus T initial. Now we can put the values. So this would be equals to, now final velocity is 45 miles per hour. So 45 miles per hour minus initial velocity we have 0, so no need to write, divide by delta T. Now this is delta T, TF minus TI, so which is 2.2 seconds. Now we'll be giving answer in meter per second squared. So for that we have to convert the unit. So we know that in 1 miles per hour we have approximately 0.447 meter per second. So this thing will cancel, this miles per hour and miles per hour. We'll get the answer in meter per second squared. So this would be equals to 9.1 meter per second squared. So this would be the average acceleration of the passenger. Now here we are given that the bacteria in human intestine have been observed to move with speed up to 15 micrometer per second and the maximum acceleration of 166 micrometer per second squared. Now consider that the bacteria in your intestine starts from rest and accelerates at 156 micrometer per second squared. So let me write first. The initial velocity is 0 because it starts from rest, so V0 is 0 and acceleration we have 156 micrometer per second squared. Now we have to calculate how much time and distance are covered by the bacteria to reach a speed of 12 micrometer per second. So final velocity becomes 12 micrometer per second. So first in the A part we'll be calculating the time to reach this much of speed. Now for that we can use this equation. V is equals to V0 plus AT. Now since initial velocity is 0 because it starts from rest, so V0 would be 0 and T would be equals to V over A. So V we have 12 micrometer per second divided by acceleration we have 156 micrometer per second squared. So from here we'll get the time to be equals to 0.077 seconds. So this would be the answer for the A part. Now in the B part we have to calculate the distance. So for that we can use this equation. V square minus V0 square is equals to 2A delta X. Now since this V0 is 0, so this whole value would be equals to 0, and from here delta X will be equals to V square divided by 2A. Now you can put all the values. So delta X is equals to, now V we have 12 micrometer per second. So we can plug it here and it's squared divided by 2A. Now acceleration we have 156 micrometer per second squared. Now we can solve this by using our calculator and we'll get the answer to be 0.46 micrometer. Now here we are given that a 27-pound meteorite struck this car and it leaves a dent of 22 centimeter in the trunk. Now we have to consider that if the meteorite struck the car with a speed of 130 meter per second, then the magnitude of the deceleration will be what? This is what we have to calculate, the magnitude of deceleration. Now initial velocity we are given to be 130 meter per second. Now the final velocity should become 0 after hitting this car. So V is 0. Now delta x, that is the dent. In this case, delta x would be the dent, which is 22 centimeter. Because in this much of a distance traveled, the meteorite comes to rest. So that is why delta x we have at 22 centimeter. That would be equals to nearly 0.22 meter. Now acceleration we need to find. So we can use this equation, v square minus v naught square is equals to 2a delta x. So from here, this would be 0. Now acceleration would be equals to minus v naught square divided by delta x multiplied with 2. Now since we have to calculate the magnitude, so we can do one thing, put it here magnitude like this. Now we can put the values. So minus v naught we have 130 meter per second and it's squared, divide by 2 multiplied with delta x we have 0.22 meter. So 0.22 meter. Now we can take the magnitude. So we'll get this value to be minus 3.8 times 10 to the power 4 meter per second squared, and its magnitude. So this would be 3.8 times 10 to the power 4 meter per second squared. So here we are given that you are driving a car with speed 12 meter per second and suddenly a ball rolls out in front of you. So you start deaccelerating at 3.5 meter per second squared. Now there are three parts that we need to solve. In the A part, we have to calculate the distance traveled by the car before stopping. So let here this is the positive x direction, and here this is x equals to 0, x not equals to 0, the origin. And suppose at this position you stop your car. So here the final velocity becomes 0, and here the initial velocity at x naught equals to 0 we are given to be 12 meter per second. So we can write it here, v naught we have 12 meter per second. Now we have to calculate this distance. Let me show it in the figure. This distance we have to calculate. So let it be delta x. Now to solve this problem, we can use equations of motion, and for this case we can use this equation, which is v square minus v naught square is equals to 2a delta x. Now final velocity becomes 0, so this term would be 0, and from here delta x is equals to minus v naught square divided by 2a. Now we can put the values. So delta x will be equals to minus, now v naught square is 12 meter per second and it's squared, divide by 2 times acceleration. Now acceleration we are given to be 3.5 meter per second squared. Because it is a deceleration, so we'll be taking a negative sign here. So minus 3.5 meter per second squared. Now we can solve this and we'll get this answer to be 21 meter, nearly 21 meter. So this would be the answer for the A part. Now next, in the B part, we have to tell when you have traveled only half a distance in part A, is your speed 6 meter per second or greater than 6 meter per second or less than 6 meter per second. So what the question is asking is, suppose at this position, at half of this distance, this total distance is 21 meter that we calculated. Now half of this distance, suppose at this position, which is nearly 10.5 meter. Now at this position, what would be the speed at which you will be traveling? Will the speed be equal to 6 meter per second, greater than 6 meter per second, or less than 6 meter per second? Now for this we can use this equation. Let me write here, this is the B part. This is delta x is equals to minus V naught square divided by 2a. Now from here we can write that V naught square is equals to 2a times delta x, and this negative sign I can take it here, and V naught will be equals to under root minus 2a delta x. Now acceleration is constant, 2 is also constant, so from here we can write that V naught is directly proportional to under root delta x. Now if this delta x reduces to half, then the velocity will be reduced by under root 2, not 2. It will not become half, it will be reduced by root 2. Therefore, at this position the velocity is 12 meter per second. So at this, the velocity should be greater than 6 meter per second. So the correct answer would be the velocity should be greater than 6 meter per second. So this will be the answer for the B part. Now next, in the C part, we have to find the speed of the car when you have traveled half a distance in part A. Now what the question is asking, that at this position what would be the speed, exact speed. We know it will be greater than 6 meter per second, but what would be the exact value? This is what we have to calculate. So for that we can use this equation. V is equals to, V square minus V naught square is equals to 2a delta x, and from here we can write that V square will be equals to V naught square plus 2a delta x. Now we can put all the values. V naught, initial velocity we have 12, so 12 meter per second, and it squared, plus 2 times. Now acceleration in this is basically a case of deceleration, so we have to take a negative sign here, so minus 3.5 meter per second times delta x. Delta x, we have to take half of this value, that is 10.5, so this would be 10.5, and this is in meters. Now we can solve this by using our calculator, and we'll get this value of V to be 8.49 meter per second, and hence we have verified also that the velocity will be greater than 6 meter per second. Therefore the velocity is 8.49 meter per second at this position.